love the chase and the hunt, and I set the pace when I'm running. I always
Namaste Friends. So today is chapter 92 in the entire Python, and in SciPy this is chapter 5. So the previous one also, we saw two parts, and today's lecture also the graph also will be seeing it in two parts. So the graph is, we all know what a graph is. Okay, we would have probably seen maybe 6th standard or maybe even the 5th standard, I don't know. So when you're actually working with a graph, the graph are an essential data structure. Okay, the SciPy provides us with a module SciPy.sparse.cs graph for working with such data structures. It can be an array like this one. Okay, an adjacency matrix is an n by n matrix where n is a number of elements in the graph, and the value represents a connection between the elements. Okay, so this is the adjacency matrix. Now, if you actually see for a graph, say suppose I take a graph, this is A, this is B, and this is C. A, B, and C, and this thing is not there. Okay, this thing is not there. Okay, so this A and B are connected by weight 1. This A and C are connected by weight 2. This C and B, they are not connected. Okay, so in this case, the adjacency matrix will be ABC, ABC. This is a matrix 0, 1, 2. So this is A to B is 1, right? So if you see A to B is 1, 0, 0. So A to C is 2, right? So A to C is 2, 0, 0. A to A is 0. A to B is 1, and A to C is 2. So that is the way you would actually read it. All right. Now, for all connected components, if you want to find all connected components with the connected components method, okay, so there is a method called connected components. Now let's take a code. So in the code we actually have this. Okay, so I do an import numpy as MP from SciPy sparse CS graph. I import the connected components because this is what I'm actually importing. I also import the CSR matrix, which is a row matrix. I have this array 0, 1, 2, 1, 0, 0, 2, 0, 0. I say the new array is a CSR matrix of this array. I take this entire thing, put it here. And then I say print connected components of my new array of this, okay, which is basically this. So when I actually run this, it actually gives me 1 comma array 0, 0, 0. So this is what it actually gives me. Okay, this is all graphs. Okay, by the way, this is all graphs. There is a next method called, I'm not sure how to pronounce this. I'm going to say digextra. So if you want to find the digextra, you have to find the shortest path. It is used to find the shortest path in the graph from one element to another. So like say like this is A, this is B, this is C. So A to B, A to C. If you want to find the shortest path, maybe this is the shortest path. So this is called the digextra. Okay, it takes the following arguments. A return predecessors Boolean is true, return the whole path of the traversal, otherwise false. Indices index of the element to return all paths from that element only. The limit is max weight of the path. So I have this. So let's actually take this, and if I actually take this, if I actually run this, so I do this import numpy as mpy, and this import. So in this case, if you see, I do a connected components because I want to find the connected components. In this case, I want to find the shortest path, so this is digextra. So I do a SciPy sparse import CSR matrix, and this is my array, and I do everything. I do a, instead of print component connected components new array, I do this digextra new array. I say return predecessors true, okay, and then index is 0. Okay, so this is what I say, and this gives me this kind of an array. All right. Tomorrow also I'll be having 4 more commands in order before I actually wrap it up the graphs. Okay, so I trust this is good for today. I trust you would have actually seen this lecture, probably understood the same. If you have any questions, kindly contact me. I'll actually try to explain to the best of my abilities. Like always, I would like to thank 2 persons. One is you for giving me a golden time, and the other is my wife Jayashree for allowing me to follow my passion. We'll be seen next time. Thank you. Take care and cheers.